I'm in a crawl space. I've got some friends. I'm at their house, and I'm gonna work on their rack, their networking rack. Look at this.
Wow, it's a mess.
Yeah.
Here you go.
Thank you. You too. Yes, sir.
You got donuts and these things?
Among my friends who are also absolute tech enjoyers, as you can see behind me, I'm the only one crazy enough to enjoy spending several hours in a crawl space configuring a network rack. My friends Andrew and Michelle, not their real names, live in a house with several other people, and they all share one router. They thought that'd be a good idea, and for the most part they're right, but there are some shortcomings that we're gonna fix today. If you hear some talking in the background, today's Super Bowl Sunday, Bengals versus Rams, but that's not what they're talking about. We're actually playing D&D, just so you know what kind of people I'm dealing with here.
I won't kick them outside.
This is the rack in question. It's gonna be a long day. Wait. Let's actually talk about what I did here and the problems that I found. So this is, in tech you do whiteboarding. Well, this is chalkboarding. See, it's a little different, it's quirky. This is just a sample sort of diagram of their network and what it looks like. At the top here, I have the internet service provider, which is sort of symbolized by a cloud. I have the router, which in this case, it's a Netgear high performance router and access point. So while it is also a router, switch, and Wi-Fi access point, they had a couple other switches as well. There was one larger, I believe it was a 24 port switch in the rack, as well as a couple other smaller ones. So of course all the clients below. In this case we have some PCs, tower PCs, laptops, phones, home security systems and stuff like that. But as far as the routers go, when I first got here, this is what I saw. ISP goes into the router, and then this router, one of the ports on the switch might go to this switch, but then it will do this, and then it will do this, and then it will do this. So this PC is still gonna work, it's still going to send and receive data just fine, but then when you start doing this, and then this, and then you have this, and then maybe you do one of these, then you run into problems. It's just not optimized. So here's what I did to fix that. So this network diagram is redrawn a little bit. I have here a more realistic depiction of the 24 port switch. I know you only say 10 on here, but just use your imagination. I also have rack mount ears because it was in the network rack, and these do definitely look like not rack ears, but like human ears. Anyways, that's beyond the point. Still, all these switches, the router, this is redrawn a little bit. The red port is the WAN port, so that goes from your modem to the router. And then these four are the four included LAN ports on the router itself. This stuff is pretty much the same down here, although you'll notice there's an access point. And this access point, if it looks kind of like one of the Ubiquiti Networks Unify devices, that's because it was. They had one of those lying around, but it was misconfigured, so I also helped them reconfigure it. But then everything else is pretty much the same. So, starting over again, ISP to modem, pretend there's a modem, there's simple RS surfboard modem that goes into WAN. So now we're at the router, and then from here, instead of doing all of this network switch chaining and inefficient stuff like that, I wanted to keep the most important functions as close to the router as possible. So this includes, let's just use one port here to the access point, and then we have another port that of course connects up our largest 24 port switch, and then finally one port, maybe it goes all the way down here to the home automation system. In reality, this line was like maybe a foot, and then this was maybe 6 feet or something like that. Access point was, of course, on the other side of the house, but these runs in general were pretty short. From there, this house does have Cat 5e wired throughout. So there's a Cat 5e RJ45 receptacle in each room, which means that this switch will go to all of these computers because these are pretend they're in different bedrooms and stuff like that. So they'll go through the wall to each different bedroom. And I made sure that the cables were wired correctly, the receptacles were wired correctly, and that the runs were verified for high speeds. And then afterwards, I pretty much used up every single port on this 24 port switch because there's a lot of rooms and a lot of devices. So from there, I really only actually needed to use one other small switch, and then I just connected the home theater stuff to this switch. So all in all, much more efficient. I could just get rid of these other switches. Before, it was a ton of wiring nonsense. Even sometimes before, we use a different color. I have a different color. Because I don't want you to think that this is how I actually set it up. But before, sometimes there'd be stuff like this, or stuff like this, when there's already this, and then there's also this. Not good. But anywho, let's get into the time lapse. So pretend that this screwdriver is a Wi-Fi antenna like you might find on a router. The antennas usually have different presets on the routers where you can have it pointing up, vertical, maybe a little bit angled, kind of like that, and then horizontal. In the case of this network installation, the router used to be in the rack on one of the bottom shelves of the rack, which is bad for a number of reasons. The location of the rack is also problematic, but there's not much I can do about that. What I mean by that is the rack was in a smaller room that had concrete walls, which, first of all, concrete is a terrible, terrible material for Wi-Fi signals to try and travel through. It just won't work. So I relocated the router to the wall because it's a whole lot better to try and get that signal to pass through drywall and wood. Additionally, I had the antennas pointing up like this, and the router itself was at around the level where someone else in the house, you might be over here or over here using a phone or laptop. That's much better. You might think that signals from the antenna travel outwards in all directions, sort of in a spherical manner, but actually the signals are strongest horizontal or perpendicular to the antenna. I should also mention something about the position of the rack within the house. It's of course not at all good practice to put a rack of critical network equipment right next to a water heater or other exposed plumbing, just in case of a leak, but there's really no other option. There's no other place for this rack. And as far as equipment that I left on the rack, it was stuff that either wasn't in use or wasn't in use that often. So for example, they had an audio receiver for the in-ceiling speakers that they weren't really using that much. They also had a NVR for old like S-video type security cameras, which didn't matter because they had already upgraded to Wi-Fi security cameras. The final thing that was left on there was the switch, which, you know, I probably should have moved it to the wall, but the wall was already so cramped. Ultimately, there's only a few people in the house who have their computers plugged into the Ethernet anyways. In most cases, you're just using laptops, or they have Wi-Fi cards in their PC, and their performance has been pretty much okay, so they're not too concerned about a wired connection. So the final thing that I didn't really address was reconfiguring the Wi-Fi speaker system. So the speakers themselves, they're in-ceiling speakers, but they have two modes of operation. One is through PoE, where each speaker is given a static IP and then linked up to the home automation system, or with just a strict pass-through, where amplified audio is already sent through the wall into the speakers. And in the case of this house, both are wired up. So my suggestion to them was to just use the audio receiver and amplifier that's already in the rack. And the reason for that is because the receiver is set up to use different zones. So you can say, oh, kitchen, living room, office, all that kind of stuff. It's already set up for that. And also because they're usually going to just use Spotify to play music. And the nice thing about Spotify is that you can control separate devices from your phone. You know, one device that plays Spotify and is linked to your account can control another device in the same home network that's linked up to your account. So the idea is that maybe you have a PC, like an old PC, that just runs Spotify. And then from each person's phone, you can say, oh, I want to play this track and I want to play it on the computer. And then from there, you can use the receiver's remote to change the zones. So at long last, we've reached the end of the video. And like always with this kind of stuff, it's really fulfilling for me to take what I've learned in terms of computers and networking and help others in need. If you're in a similar position where you know something about something and someone asks you to help, absolutely go for it. It's super fun, it's super fulfilling, and I always enjoy this kind of stuff. So as far as videos on the channel go, I have some fun things in the pipeline. Something that's not really too well known is that I used to do a lot of electrical engineering. I wouldn't call myself an electrical engineer because I have like zero training, but no training doesn't mean that you can't still play around. So I think it's time that I play around. Anyways, Thanks for watching. Namaste.